The coolant temperature sensor is normally located at the top of the engine close to the thermostat, where engine coolant is generally at its hottest. The engine computer uses the output from this sensor to determine how much fuel to spray into the cylinders for the most efficient burn. Cold engines require more fuel in the fuel-air mixture, with the amount of required fuel decreasing as the engine reaches full operating temperature. When a coolant temperature sensor completely fails, the engine computer may receive a signal that the engine coolant is very cold, even if the engine coolant is actually hot. This results in a very rich fuel mixture, potentially adding so much fuel that the engine will not run. Defective temperature sensors will normally cause a diagnostic trouble code to set, turning on the check engine light.
It consists of a brake pedal, a master cylinder, wheel speed sensors, the electronic control unit or ECU, and the hydraulic control unit, also called a hydraulic modulator. The wheel speed sensor consists of a notched or toothed rotor that rotates with each wheel and a pickup. As the wheel turns, a small voltage pulse is induced into the pickup and sent to the electronic control unit. When the brakes are applied, the wheel's speed of rotation changes. This sends a new signal to the ECU. If the control unit detects that a wheel might lock, it sends a signal to the hydraulic control unit. In a 3-channel system, the hydraulic control unit uses 3 solenoid valves to control brake pressure and prevent them locking. The valves are in series with the brake master cylinder and the brake circuits. One operates for each of the front wheels and one controls both rear wheels.
The timing belt connects the crankshaft at the bottom of the engine with the camshafts at the top of the engine. The teeth on the belt and on the crankshaft and camshaft sprockets ensure that the valves open and close at exactly the right times. The intake valve opens to allow fuel and air into the cylinder, then closes as the mixture is compressed, then ignited. Then the exhaust valve opens to allow the waste gases out. Timing belts are lighter, quieter, and more fuel efficient than metal timing chains, but require replacement at manufacturer-recommended intervals. If the belt breaks when the engine is running, it is possible that valves can become stuck in the open position and bent by contact with the piston. During the timing belt replacement, the hydraulic tensioner that keeps the belt tight should also be replaced to prevent future failure as a result of reusing worn parts. On many vehicles, the pump that circulates coolant or antifreeze around the engine is also driven by the timing belt. Replacing this pump at the same time as the timing belt avoids the risk of the pump leaking or seizing as a result of worn bearings.